My name is Hunter Hines, and I am presenting my speech on radiation. There we go. The audience. So, radiation. What comes to mind when I say the word radiation? For most people, the answer to that question is probably things like cancer, nuclear bombs, probably going to be up there. According to the International Atomic Energy Association, most of our radiation exposure in a day comes from things like the sun, microwave ovens, and radios. In the modern world, man-made radiation is becoming more and more common, but the general population's understanding of it hasn't really increased. I've written several papers on similar topics, and being a chemistry major, I have a lot of exposure to learnings of this sort of thing. To start off, we will learn what radiation is. Move my camera so you can read that. We'll learn what radiation is, where it comes from, what it does, and how it's used. Start off. What is radiation? Once again, according to the International Atomic Energy Association, radiation is energy that moves from one place to another in the form of a wave or particle. There are two kinds of radiation. There's non-ionizing, which is a form, and ionizing. I'm remembering my format. Non-ionizing is lower energy. It's generated by things like microwaves, radios, and light bulbs, and is generally the safer of the two kinds of radiation. The only real risk from non-ionizing radiation is heat. So if you're exposed to large amounts of non-ionizing radiation, you would want a way to protect yourself from the heat, but the radiation on its own is not particularly dangerous. Ionizing radiation, on the other hand, is higher energy. It comes from things like X-rays, nuclear power plants, and of course the titular nuclear bomb. This is generally considered to be the more dangerous of the two kinds of radiation. Where does it come from? Ionizing radiation comes from the breakdown of unstable atoms, these are usually called radioactive atoms. Some elements are just unstable, like uranium. Generally, anything past bismuth on the periodic table would be considered radioactive. Some are unstable forms of stable atoms. These are called isotopes. Carbon-12 and 13 are stable isotopes of carbon. Carbon-14, on the other hand, is radioactive. And some radioactive atoms are just made in the process of radioactive decay. As you can see here, there are three kinds of radioactive decay that we'll be going over: alpha, beta, and gamma. Alpha decay is the breakdown of atoms, which involves the release of a heavy, positively charged particles in order for a radioactive particle to become more stable. In the example here, we have uranium-235 breaking down into thorium-231 and helium. Helium is our positively charged particle of note that is released with alpha decay. This is the least dangerous of the ionizing radiations. These particles can be stopped with like a thin sheet of aluminum and generally aren't able to break skin. So they're only dangerous if you were to eat them. Beta decay is when a neutron becomes a proton by releasing an electron. The example given here is carbon-14, as we mentioned earlier. Through radioactive decay, will become nitrogen-14, which is a stable atom, and an electron. These are more dangerous, but really not the most dangerous thing you need to worry about when it comes to ionizing radiation. What you do need to worry about is gamma waves. Gamma waves are released when an extremely energized atom moves to a more stable state. So in the example here, we have cobalt-60, which goes through beta decay to become nickel. That nickel is very excited, so it will give off gamma rays to lower its energy and become more stable. These gamma rays are extremely dangerous. They're very easily able to pass through your body and do some serious damage. The best way to combat gamma rays is thick layers of concrete and or lead. Non-ionizing radiation comes from a lot of sources. ELF, or extremely low frequency radiation, is generated by power lines and electrical circuits of all kinds. Radio frequency and microwave rays, they're pretty self-explanatory. Radio frequency comes from radios. We use them in a lot of ways. And microwave radiation, I think, was originally designed for that same purpose, for radio wave, but eventually got moved into its more common uses nowadays. And light. All forms of light, whether it be UV, infrared, or the visible spectrum, are all considered radiation. Again, the only real source of harm from these comes from heat. What does it do? It depends on the dose. The dose of radiation is measured in sieverts, though that measurement is rather large. 1 sievert of radiation is more than enough to kill you. So it's generally measured in micro or millisieverts. Acute exposure, which is a lot in a short amount of time, can result in things like nausea, vomiting, skin redness, hair loss, radiation burns, and death via total organ failure. It's not pretty. Long-term exposure, which generally includes low-dose radiation over an extended period of time, can lead to a lot of these same symptoms, and as well as increased cancer risk. Again, the exact method of protecting yourself depends entirely on the ionizing radiation. But in most human lifetimes, we are only really exposed to 0.3 millisieverts a year of radiation. So, not too much. How is it used? Non-ionizing. Microwaves, ovens use microwave radiation. Who would have guessed? Cell phones, as well, use this microwave and radio frequency radiation. And radios use radio frequency. Again, who would have guessed? Ionizing radiation, alpha radiation, is used in smoke detectors with americium-241 being used in smoke detectors globally. Beta radiation is used in powerless emergency lights. Basically, in the decay process, it causes phosphorescent materials to glow without the need for electricity. Commonly used in the example given here for exit signs if power goes out. And gamma rays are used in all sorts of medical settings, from X-rays to cancer treatment. It's used all over. There's a number of ways to use radiation in your everyday life, and it's, I feel, important to understand how it impacts you. In summary, radiation is a form of energy, taking the form of a particle or wave that moves from one place to another. Non-ionizing radiation comes from the decay of radioactive particles. Well, did I say non-ionizing? I meant ionizing. Excuse me. Ionizing radiation comes from the decay of radioactive particles, while non-ionizing can come from a lot of sources. And the effects of radiation depend on the type, dose, and length of exposure, and it's used in all sorts of various ways. Radiation is a complex phenomenon, and as we've seen, can be used in a lot of different ways, anything from generating electricity to treating cancer. Because of this, it has the capacity to harm and to help in equal measures. And proper education on what it is and how it's used is important to help prevent potential disasters like we've seen in the past with Fukushima and the Chernobyl meltdowns.